Alright, so we're starting chapter 6 now. This is 6.1, similar polygons. And basically all this is just shapes that are basically exactly the same except different sizes. And it's always going to be about proportion. So basically all you need to know how to do for this section is cross, multiply, divide, just like pretty much the whole course. It's a huge skill, and we're going to continue on with that. So this first part of the page 254 is absolutely critical to similar figures. You must memorize these two bullet points. For two figures to be similar, you have to have angles that are the exact same, and the sides have to be in proportion. And it says corresponding angles and corresponding sides. So what they mean by that is that you have to match it up. So for example, AB goes with WX, DC goes with ZY, and so on. And like angle A goes with angle W, and angle B goes with angle X. So you have to match it up with the corresponding angle or side in the other shape. That's basically what this whole page is going after. And you can read example 1 if you'd like. I will start with example 1 on build your skills. It says the two figures below shown are similar. Find the lengths of the sides of the smaller figure. And the diagrams are not to scale. So the formula that I will use is called scale factor formula, and it is model divided by original. So basically it's the new dimension divided by the old dimension. So remember that you have to correspond sides. So LM goes with AB, and you can see that AB is 15 and LM is 5. So the ratio that goes for the model divided by the original, we'll call this shape the model, we'll call this shape the original. So the shapes look similar. All we have to do is prove it using the scale factor stuff here. So 5 divided by 15, those two dimensions there, is equivalent to, let's find LP. LP highlighted in blue here goes with AE. So the model on top is LP, the original on the bottom is 21. Like it's highlighted in blue there. Cross multiply divide. 21 times 5 dividing 15, and I get that LP is 7. And you can continue on with this process and you can find all the other sides. So OP, ON, and MN, you can all find those using similar techniques. Use 5 over 15 as your guiding ratio, and then you solve for the unknown side. So if you want to find OP, you're going to have to use the corresponding side on the original shape. OP goes with 18, cross multiply divide, and you can solve these. So I'll leave those for you to do. Number 2 says on a blueprint, and a blueprint is a model of a room. So on a blueprint, a room measures 2.75 by 1.5, so that's the dimensions of a rectangle. 2.75, 1.5. There's your rectangle. It says if 1 inch represents 8 feet, what will the dimensions of the room be? So this is called a scale statement, and often these are used on blueprints or maps. So 1 inch equals 8 feet. Now we have 2.75 inches and 1.5 inches. So all you have to do is put the corresponding inches in the ratio and solve for x feet. Cross multiply divide, 2.75 times 8 divide 1, this was 22 feet. So this one will go to 22 feet in the original room, the actual bedroom. And the other one, instead of putting 2.75 here, we can put 1.5. Similar process, and you get this one is 12 feet. So what do we do? Just reiterating what we did. We were given the dimensions of the model, and then we found the dimensions of the original, which were 12 feet and 22 feet. So these are the dimensions of the actual room, or the original room, and the dimensions of the blueprint is what we started with. So the blueprint is the model, and here the actual is the original. Alright, so now looking at number 3, they want to identify similar polygons. And I guess they just want us to see which sides are in corresponding ratios. And I don't really like this example, so I think I'm going to skip it. Okay, let's go to a example 4 here. Okay, it says if two polygons are similar and the following angle measures are given, state the corresponding angles and their measures. Well, if similar, all corresponding angles are equal. And in fact, when you're doing your test, you're going to feel like questions like this are almost too easy, too good to be true. But it is in fact true. So if J is 73, then the corresponding angle, I guess J would go with D. D is 73. It's exactly matches. So if B is 21, I guess B would go with H. H is 21. So they have to be identical angles. Alright, so let's take a look at the next one. It's a similar question. A goes with X, so X is 32. C goes with Z, so Z is 48. These are degrees, so that must mean B, the last angle here, is also 100. Okay, so make sure you remember that all angles in similar figures are equal. The corresponding angles are equal. So question 6, if trapezoid PQRS is similar to trapezoid LMNO, what are the values of W, X, Y, and Z? So what's happened here is, looks like there's been a rotation. So it's like, if I could just pick this angle up and rotate it, or pick up that shape and rotate it, I would see it just fine. So what I'm going to do is I'm going to re-sketch it. So here's L, here's O. And I'm rotating this in my head. So down here would be N, and here's M. So LO is 20. ML is Z. NM is X. And the angle at N is 42 degrees. And the angle at M is Y. Alright, so now I can use my highlighter to show you that like PS would be similar to LO. So right away I can get that the scale factor is going to be, scale factor is model divided by original. So the scale factor here is 20 divided by 40. So this is the ratio that I'll use to guide everything. So for example, if I want to solve for X, I'd have to use 90. Okay. So using my guiding ratio of 20 over 40, I can solve for X. So it'll be, if 20 goes with 40, X goes with 90, cross multiply, 20 times 90 divided by 40, so X is 45. And they want me to find Z as well. Z is on connecting M and L. So using my highlighter, ML goes with 35. And at this point I've realized that all that's happening is that you're dividing by 2, because the scale factor is 1/2. You can see 40 goes to 20, 90 goes to 45. They're being cut in half or divided by 2, which is exactly what this scale factor says. 1/2 means times 1/2 is identical to dividing 2. So for this 35, all I have to do is divide by 2, and I know that Z is 17.5. And they want me to find angle Y. Angle Y, use my highlighter so you can see in purple. Angle Y is exactly this angle there. So angle Y is 70. Alright. Okay, I didn't like example 3, so we're going to skip that. 2 questions here. It says if a house is 40 feet by 35 feet and the top of the roof is 27 feet above ground level, what will be the corresponding dimensions be of a model built so that 1 foot is represented by 1/2 of an inch? So if 1 foot is represented by 1/2 of an inch, I'll just change 1/2 to a decimal. Then all I have to do is take these individually and cross multiply. Line up the units with the units, so 40 would go here, x inch, and you cross multiply. And you do them all separately. So this would be 20 inches. After cross multiplying, you'll see it 17.5. And this one is 13.5. Number 9 says origami paper is being folded. The outer box is given. Teresa would like to make 3 smaller, similar boxes, each scaled down by 1/4 of the previous box. What are the dimensions? So all it's saying is that 1/4 is the scale factor. And what you have to do is take each dimension, so for example 12 centimeters, and multiply by the scale factor. Same with the 8. And same with the 4. And in fact, this is what you always do with scale factor. For example, if you wanted a rectangle to be, if you wanted the dimensions to be twice as big, say you'd like 3 to become 6 and 4 to become 8, all you do is multiply by 2. Multiply by 2. And that would be called your scale factor. So all I'm doing here is multiplying by 1/4. So 12 multiplied by 1/4. 8 multiplied by 1/4. And 4 multiplied by 1/4. And you get the following answers: 3, 2, and 1. And these would all be the dimensions of a similar box. So work on practice your skills. Number 1, 2, 3, 4, and 5. And 5 looks like the only one that's pretty challenging. The rest of these look pretty decent. So good luck.